Module 3.3 looks at generic redirection. This is the use of control structures for jumping to different instructions in the code. So again, this was included largely because C was designed to replace assembly language. And these generic redirection control structures directly mimic the designs used in assembly language, things that were designed very much for performance, very much for efficiency. C continues to maintain them as part of the C language standard, even though they are largely unnecessary. Many experts essentially recommend only using them if they are absolutely necessary, purely for the sake of optimization, if at all. And part of the reason I'm including them in this course is it helps to understand them. You may see code that uses them. Some of them are actually commonly used despite recommendations. And it helps to know what can go wrong if you're using these mechanisms and why they can be dangerous, and how you can avoid the pitfalls of their use. So the first couple of keywords to mention are break and continue. Break and continue are not necessarily constructs like the if and the while and the for that we've talked about, but more jump statements. Break and continue are statements that directly modify the instruction counter to jump to different locations within the code. Now, the break instruction is used often, but not always, inside of a loop, but used essentially inside of a block of code. And what the break instruction is going to do is it's going to essentially abandon the block of code and go to after that block of code. So if it's in a loop, this is quite literally breaking out of the loop. And in this example shown here with the while loop, I have a break inside of a condition. And if this condition B is ever true and this break is reached, the control is going to jump out of the while loop and start executing the linear next instruction after the while loop is done. So this is independent of the loop condition of the while loop, potentially. And it's a way of essentially abandoning the while loop entirely. Now, compare that to a continue statement. Rather than jumping out of the while loop entirely, a continue statement will jump to the next iteration. So essentially, a continue statement will abandon the rest of the current iteration of the loop and go back to checking the loop condition and continuing if the loop condition is still true. So it still jumps, but rather than jumping out of the block, it jumps to the end of the block. And since you're still within the block, you're still within the while construct, and the next thing to do is to check the loop condition. So both continue and break can potentially be useful. They both have their places where they can be used. Just directly jumping to particular locations, which is either the end of the loop body or one after the end of the loop body. Now, there are cases where the continue statement in particular can be, we'll say, interesting. It can create some ambiguity, and this is one such example. So in this example, I have a while loop containing a while loop containing a conditional continue statement. And recall now, we just said that the continue statement jumps to the end of the loop body. Well, we're inside two loop bodies. So which one do we continue to? So this is a point of ambiguity. If there is no construct to deal with this, this is not a well-defined operation. And all operations need to be well-defined. So this means there needs to be a mechanism to say, I want to jump to the end of the inside while loop, or I want to abandon the inside while loop and jump to the end of the outside while loop. So if I can continue, I should be allowed to do both of these things. That I should be able to facilitate both of these. But one command can't do both of those. So this actually means by using the continue command in this case, we necessarily need something else to differentiate between continue the inner while loop versus continue the outer while loop. There's no construct to do this, so we need to introduce something. And it turns out what C allows for in this case is it allows for the use of labels. Now, labels aren't usually used in C. They're very commonly used in assembly language. A label is nothing other than a name for a line of code. Now, in C, we have names for variables. We have names for functions. But a label is a name for a position within the code. So in this case, we're defining a label called outer, and it refers to the line of code where the while loop starts. So now, the reason that this disambiguates the two cases we were talking about is if we just say continue, what this will do is it will continue the innermost while loop, which means control changes to the end of the innermost while loop, and the innermost while loop continues executing. So when this continue is encountered, the next thing that will happen is condition B will be checked for the inner while loop. Now, if we have this label labeling the outer while loop, and we say continue outer compared to just saying continue, this is now saying continue to the label outer. And this is equivalent to jumping to the end of the inner while loop, because if we were to jump to the end of the inner while loop, the next thing we would do is we would check the loop condition. By saying continue outer, we're actually jumping to the label outer, and the next thing we do is we encounter the while loop and we check the loop condition. So this achieves exactly what we want, but now it requires the use of this label to realize this functionality. And C wouldn't otherwise want to support labels. Now we have to support the continue statement and allow it to be used within nested while loops. Now, the next control structure that falls in this category of it only exists because it was part of assembly language is the switch statement. And this one might be a little bit of a surprise because switch statements are used by a lot of different modern programming languages. A lot of people really like using switch statements. They've become very popular. But the only reason this was included in the C language standard to begin with is it's because it's equivalent to assembly language construct called a jump table. And a jump table basically says you look at the value of a variable and you jump to a different label in your code base, a different position in your assembly code based on the value of the variable. So this is realized in the control structure shown here that we talked about earlier, where as the control flow comes in, looks at the value of a variable and takes a different branch through the code depending on the value of the variable. Integer type variable, because we need to be able to test equality. So this is equivalent to a sequence of nested if checks. Syntactically, a switch statement takes the variable that it operates on, and we provide a list of cases that we want to check. And each of these begins with the keyword case, which is essentially unique to the switch statement. Each case includes a label, and each label is one of the potential values of the variable. So the way to read this is, in the case that the variable takes value 0, we execute instruction 0 and then break. In the case that the variable takes the value 1, we execute instruction 1 and then break. And note, the breaks are required, because otherwise we will execute code linearly. And labels don't do anything functional. They're just references to positions in code. So reaching a label doesn't actually accomplish anything. If this break is removed, once this instruction is executed, we'll continue right on and execute this instruction. So to end each case, we need the break statement to basically say, now I'm done, leave the switch statement. The default is something that can be included optionally in a switch statement, and this is essentially a catch-all. This is like an else. So in the event that the variable doesn't match any of our cases, we execute the default statement, and we don't need a break at the end because we're already at the end. There's nothing to break out of. So in summary, the case label is somewhat equivalent to testing, is the variable equal to this particular value? The break is more or less equivalent to the end of a clause in an if statement, and the default is more or less equivalent to an else in an if statement. Well, if that's true, why not just use if-else statements? We really don't need this switch statement. We really don't need to worry about cases. We really don't need these labels. We don't need to worry about these breaks. We could rewrite this whole thing just using standard if-else logic as long as we're careful with it. An example for when this might actually be used commonly, one example that I put together was if you have large data type like a 32-bit integer, but you only care about a few select values, you might put together a switch statement where you can quickly jump through those few values. In this example, I imagine the use of a 32-bit integer to encode, unsigned 32-bit integer to encode color values, red, green, blue alpha, or red, green, blue transparency values. And if you wanted to do some special processing, if the value was any number of or any one of a small number of special things like solid red, solid green, solid orange, solid yellow, black, white, and then a default for all other colors, you could use a switch statement to do that. And you could basically match on the cases for the colors that you care about. This is solid red, this is solid green, and then you have an else or a catch-all for all of the other possible colors. You can do this with a switch statement. Of course, you could also do this with an if statement and just do if color code equals this, then red, if color code equals this, then green, and so on. Potential dangers with the switch statement are actually related to some interesting parts of its design. So one aspect of the design of the switch statement is the break. Since the break is required to jump out of the switch statement, that means you can eliminate the break and intentionally fall through from one case to the next. If the break wasn't required, if each case immediately broke out, this fall through wouldn't be possible. This was designed in a way that the fall through is explicitly supported by leaving out the breaks. What this means is you can have a switch statement that executes the same line of code for multiple different cases. This essentially acts like a logical OR. So if I have a switch on a variable, I have multiple case labels, and then an instruction and then a break. This instruction will execute when this variable is equal to any of these three values. So this is like if the variable is value 0 or value 1 or value 2, then execute this instruction. Again, we can do this with an if statement with more complex logic in the if condition, but this is actually a tiny bit faster because of how the labels are interpreted and how things are built in at the assembly level. It's actually going to be faster in the machine code. You might be able to imagine, however, if I accidentally forget a break statement, and I think I've written my switch statement correctly, it will compile, it will run, but the behavior will be really weird because in addition to running this instruction for values 0, 1, and 2, it will also run this instruction for values 0, 1, and 2 if this break is missing. This is hard to debug, potentially. And it makes the code, it's a little bit harder to read. If I was using if and if-else statements, it would be very clear. And that is not a mistake that I would make. So that's a potential danger and potentially a reason to avoid the switch statement. So what most people would argue is to just use if-else statements because not only is this easier to read, it's actually like human readable if variable equals value or variable equals value or variable equals value, perform this instruction. Not only is it easier to read, it's harder to make mistakes because there's no break to accidentally forget. There's no case that can fall through. This is more explicit. It's a little easier to read. It's actually fewer lines of code. Yes, you take a little bit of a hit in terms of a few more clock cycles of execution time, a little bit of performance, but that's probably okay with modern computers. So in many ways, this is just all around better for writing the code, reading the code, and debugging the code. So the last redirection mechanism to talk about is the very, very well-known goto statement. The goto statement, again, is one that uses labels to allow for jumping around within program code, jumping to different lines of code. It is very, very widely believed that the goto statement should not be used anymore, yet it is still supported. There are a very small number of extremely rare cases where it's acceptable, widely acceptable, believed to be acceptable within C code to use the goto statement. This example is not one of them. This example is, in fact, something that we already have a control structure for in C that we can use without labels. But the way that goto works is, again, you define a label that points to an instruction. When the goto, that label, is used, the instruction counter simply sets itself equal to that, and control goes back to that instruction. So in this case, I encounter this instruction 0, instruction 1. I check this condition. If this condition is true, I go back to label 0, or label X, run instruction 0, instruction 1. Then I check the condition. If it's true, I go back. This is a do-while loop. This is exactly a do-while loop that we already have in C. I execute my instructions. This is my loop body. Then I check my loop condition. If it's true, I continue. If it's true, I continue executing the loop. So this is nothing other than a do-while loop. The challenge is we don't have a clear indicator other than the label of what is included in the loop body. And there's nothing explicitly that says that this is a loop. Because it's possible that this could jump to arbitrary places in code and not actually be a loop. It's possible that we could jump around multiple different places and eventually become part of a loop. It's much less clear than using something like a do-while loop. So why use it is sort of the question, and the answer is you shouldn't in this case. Yet goto is still supported because in assembly language, this is a direct branch statement or jump statement, depending on what variant of assembly language you're using. In this case, it's a conditional jump or a conditional branch. All right, so let's look at a couple of examples. So let me pull up the terminal once again. I've created a little bit of example code going beyond just these simple snippets, something that's actually runnable for these other control structures that we have. So let's look at this code and see what's here. These are things that I constructed purely for the purpose of saying these things are legal to do. This is code that will compile and execute, but probably is not the right way to write C code. These are all things that can be done much more simply, much more clearly. So let's go through them one at a time. The first loop is, I have an infinite loop, and I want to terminate that infinite loop as soon as a certain condition occurs. Well, just by saying this, there should be a better way to do this. Rather than defining an infinite loop that terminates when a condition is reached, I should just create a loop with a condition that's not infinite. So if I take this, so instead of having an infinite loop that then checks a condition and breaks if that condition is true, I should simply put the opposite of this condition as my loop condition. If I put the opposite of this, the opposite of this being counter is less than loops, I could simply say while counter is less than loops. And then these two lines of code would be gone, and this would be the same. This would be a standard conditional while loop. So why not do that? If you see an infinite loop with a break condition, you might immediately ask yourself, why is that an infinite loop with a break condition? And that's a good question to ask. The second example is, what if I want to skip an iteration of a while loop? So here I have a more standard while loop, while the counter is less than the number of loops, but I want to skip the iteration when the counter is halfway there. So as soon as the counter value reaches loops divided by 2, which in this case is 5, I want to skip the print statement and continue, which essentially skips the print statement and continues with the next value of the counter. Well, this is legal. This will print 0, 1, 2, 3, 4, 6, 7, 8, 9. It'll skip printing the value 5. This is legal. Is this the best way to do this? No. What you could do instead was take the opposite of this condition, namely counter not equal to loops over 2, and put the print statement inside of that. If you put the print statement inside of that, you take the increment out, you leave the increment here, then this is going to print 0, 1, 2, 3, 4. When it reaches 5, the if statement is false. The while continues on its own, and it executes very nicely. You don't need the continue. You don't have the potential ambiguity. You actually have fewer lines of code. You have one less line of code, two fewer lines of code. Things are quite a bit cleaner. Why not just do it? Similarly, you can do this with for loops. You can have a for loop that, rather than a loop condition, uses an if statement with a break. This is completely legal to do with a true as the loop condition. For loop will continue forever. The break will break out. You can do this. Why would you do this? I don't know. Put the opposite of this in the loop condition. It's much cleaner. Put counter less than loops in the loop condition. You get rid of these 2 lines of code. In that case, you have a 1-line loop body. It's very simple, very clean, very easy to do. Similarly, for for loops, we can skip over the case where we're printing the value 5. This is the same as the while loop example above, just with the for loop. We still have the loop condition. Now we're just checking if the counter is loops by 2, then we just skip the print. This could very easily be if the counter is not loops by 2, print. To get rid of the continue. Things are just cleaner. It's much simpler. It's easier to read. It's easier to understand. We can get rid of that continue. We can also look at examples that use labels, things like goto and break and the nested while continue. This is an example much like the one in the code, where we have a initializer for the counter value. We're creating a loop using goto. We have a condition that we're checking for the loop condition. We're printing things in case of the loop condition. If the loop condition is not true, we continue past our goto and we break out of our loop. This is kind of nasty. I would say never do this, because it's not even, you have to do a bit of mental parsing to even figure out what's going on here, to figure out what this is going to do. Once you know what it's doing, it's kind of clear to say, oh, this is performing the same loop as the other things. But it's using labels, which is nasty. It's not very C-like. It's using goto, which is unclear. It's not exactly clear that this is a loop, because it's just an if statement with a goto. It's asking to be confusing. So just don't do it. just don't use the goto. It's evil. It's nasty. Never use it. There are ways to do things much cleaner. There are valid uses of labels, as I mentioned. There are cases where you can do the double while, where you want to break out. Again, I'm not going to go through this code line by line. This code could be rewritten to not have to use the label and the goto. And in fact, it's not that hard to do. It's just a little bit more logic to work things out to make it so it's actually clean, so it uses better coding style. Just avoid this whenever possible. I did just want to mention, like I said, all of this is legal. This code will compile, it will run, it will print numbers according to things that we expected. This is the standard loop, this is the loop using break, this is the loop using continue to skip the number in the middle. This is the for loop using the loop using goto and the label. This is the output of that more complicated logic at the end. You can go back and you can look at this code and see what it's all doing. Again, keep it simple. Use the constructs, the while, the do while, the for loop that are provided. You really shouldn't need breaks. You really shouldn't need continues. You really shouldn't need labels. You can use them if you really get into optimization of code. If you really get into cases where every clock cycle matters, by that point, you're probably going to be an expert C programmer. And you will be much less likely to fall into the pitfalls. You will likely be a much better programmer and a much better debugger by then. It's okay to use these things then. Don't use them for now. That's where we're going to stop for Module 3. By this point, you can basically, you'll be able to realize arbitrary control flow. Using conditional execution and loops, you'll be able to differentiate among which control structure do I need, which ones to use in different situations, which ones to avoid entirely. Through the programming tasks, you will even learn how to restructure code that uses breaks and continues and gotos, how to restructure the code so that it doesn't. We'll continue on in the next module. We'll get into even more interesting structures within the C programming language.